Okay, so this is section 4.3, and this is going to be kind of a more complex or complicated version of 4.2. So I'm going to do this entire section through an example. Solve cosine 5x plus pi over 4 equals root 3 over 2 for x, all right? Okay, so immediately we see this is complicated because this stuff is inside the cosine. And so we can't do it kind of as simply as the stuff from the end of 4.2, all right? Oh, by the way, once I finish this particular problem, I'm going to add one more kind of complication or one more sub-question. So this is kind of like going to be a multiple feature problem. Okay, so how do we do this? This 5x plus pi over 4 is really unpleasant. So like I said in the last lecture, and like I always say in the math class, we want to transform problems that are complicated into ones that we already know how to do, right? So this problem looks very complicated, and the ones we know how to do are solve cosine of x equals a number, solve sine of x equals to a number, solve cosine or tangent of something equals to a number, a variable, right, equals a number. So I'm going to transform this into exactly that. And the way I'm going to do that is by making up a variable name. So when I make up a variable name, I use the word let. So let y equals 5x plus pi over 4. All right, so this is very important, so I'm going to put it in a box. I'm going to refer to this at the end of the problem again. Okay, so why do I do this? If I make up this variable y, which is 5x plus pi over 4, then my problem becomes, then we need to solve cosine of 5x plus pi over 4 is y, right? Cosine y equals root 3 over 2. All right? And now this we're really, really happy with because this is 4.2, right? This is exactly a problem from 4.2. Okay? So that means we can do it, right? And so we're going to do it. We're going to solve this problem. We'll get y, and ultimately we're looking for x, right? When we say solve blah, 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 and then we have an x there, we want our answer to be x equals this or that, right? So when we do this part of the problem here, solving for cosine y equals root 3 over 2, we're going to get a y equals blah, blah, blah. So after we do that, we're going to have to convert back to x's. Okay, so that'll be the new part of this type of problem. Okay, so this part of the problem is exactly 4.2, right? So how do we do this? Very, very quickly. I'm going to draw cosine. And let me do it using the version where I look between 0 and 2 pi. Like that. Here's pi. I know cosine of, so I know cosine of pi over 6 is equal to root 3 over 2, right? So here's pi over 6. And so this height here is root 3 over 2. And so that's going to be pi over 6 is going to be one solution to this cosine y problem. And I'm going to get another solution right there, right? Where is that? Well, this hump goes this way. And if I think of it as having a direction, I'm moving from the top of the hump to the bottom, to the ground, right? If I think about it with a direction there, then I'm moving from 0 to pi over 6 to get to my solution. Okay, if I do the same thing kind of symmetrically from 2 pi, I would be moving to the left like this, from the top to the ground. All right, from the top to the ground. And in this kind of direction, that means I need to move from 2 pi to the left a distance of pi over 6. Okay, so this point right there has to be 2 pi minus pi over 6, which happens to be 11 pi over 6. So ultimately, my two sets of solutions are going to be y equals pi over 6, y equals 11 pi over 6, right? And again, y, because I'm solving this intermediate problem right here, right? And this will lead me to the x solution, but I need to solve this one first. Okay, plus 2 pi k plus 2 pi k, right? So these are all the solutions in terms of y. Okay, so this is entirely 4.2 between these two lines. That's 4.2, all right? Okay, like I said, I want x, right? My problem was given in terms of x, so I want my solution to be in terms of x. So how do I convert from y to x, right? Well, I use this right there, right? Y is equal to 5x plus pi over 4. And so that means this guy right here is 5x plus pi over 4. That guy right there is 5x plus pi over 4. So what I'm going to do is I'm going to split this into two problems. Let me write over here. Y is equal to 5x plus pi over 4. So this number 1 gives me 5x plus pi over 4 is equal to pi over 6 plus 2 pi k. All right? And let me call this one number 2. Number 2 gives me 5x plus pi over 4 equals 11 pi over 6 plus 2 pi k. All right? Now all I'm going to do is I'm going to solve for x, because ultimately I want x equals something and on the left, and x equals something on the right. And those will give me my two groups of solutions, right? My two sets of solutions. So I'm just going to solve for x using algebra, just regular algebra. And it might look kind of weird that there's a k here, but remember, k is just a placeholder for any integer, right? 1, 2, 3, 4, 5. So it's not an unknown variable in this problem. So x is the only unknown variable. All right. Let's just do our algebra then. So here is just algebra. I need to, for the left, I'm going to do the left side entirely first. So I'm going to throw the minus pi over 4 to the other side. So this is the same as 5x equals pi over 6 minus pi over 4 plus 2 pi k. Let me simplify that. That's equal to common denominators. This is going to be 12, 2 minus 3 plus 2 pi k. That's going to be minus pi over 12 plus 2 pi k. That's 5x. All right. I want x, so I'm going to divide by 5 on both sides. So x is equal to minus pi over 60 plus 2 over 5 pi k. Okay. All right. So that's it. This is going to be one group, kind of collection of my solutions. K can be any integer again. My other collection, I go to the other side and I do the same things. So this is going to be, I throw the pi over 4 to the other side. 5x equals 11 pi over 6 minus pi over 4 plus 2 pi k. This is, sorry, let me just simplify that. This is common denominators again. This is going to be 6, 22 minus, sorry, I forgot the pi here. Pi. 22 minus 3 pi plus 2 pi k. That's going to be 19 pi over 6 plus 2 pi k. Okay. All right, so x is equal to, divide by 5 on both sides. I get 19 over 30 pi plus 2/5 pi k. All right. So now I have my x's. And so I can write my solution, x such that x equals minus pi over 60 plus 2/5 pi k. X equals 19 over 30 pi plus 2/5 pi k. K equals integer. All right. And again, if you're asked to write down a specific solution, then you know, or let's say a bunch of solutions, 3 solutions, then you could use k equals 0. K equals 0, that gives you 2. K equals 1, that gives you another one, right? And so on. So you can write down as many solutions as you need. Okay, So that's the idea for the first part of this section. Uh, if the problem was in terms of sines, you do the same thing, right? If the problem were tangents, you do the same thing. Again, the main key is to create this new variable y, to solve a 4.2 problem in terms of the y, and then to solve for x because you know you have a formula that relates x and y. Okay, so the second type of problem that, or kind of a refinement or a modification or a variation of this kind of problem is something like this. So I'm going to write down the same exact problem. Solve cosine 5x plus pi over 4 equals root 3 over 2. Except I only want solutions for x between, let's say, pi and 3 pi. All right. So here, this is a kind of interesting problem because now we're not looking for every single x. We're only interested in specific x that's between these two numbers. Okay. On the homework, in the online homework, I believe almost all the problems, maybe all of them, are going to be where you want x between 0 and 2 pi. And our book likes to, well, the problems that he specifically asked are bigger than or equal to 0 and then less than 2 pi. All right. But you can ask anything. That's why I emphasize that I could have a pi here and a 3 pi here, anything. Okay. And a notation I think the book uses is x in 0 to 2 pi, like that. All right. So just note that these two mean exactly the same thing. So here I could rewrite this as x in pi to 3 pi. So this means in. So in the interval, all right? This means in. Okay, so how do I do this? Well, the way I do this is I do the first problem first. I do this problem first, all right? And I get the solutions. So we've already done that, luckily for us. So now I'm going to write down the solutions. We did this part, right? And the solutions were x equals minus pi over 60 plus 2/5 pi k. And x equals, again, we're going to treat each of the two sets of solutions differently. So I need to write them kind of separately. Okay, now what do I need? I'm looking for x between pi and 3 pi. Okay, so here's my x. I need it to be between pi and 3 pi, right? So, sorry, let me put a line here. I want pi less than or equal to x less than or equal to 3 pi. X is literally on this side of the screen, on the left side of the screen, x is that, right? So I'm just going to replace x with that. So that's the same as pi less than or equal to minus pi over 60 plus 2 over 5 pi k less than or equal to 3 pi. All right. So I'm looking for, I need this condition to be satisfied, right? If this condition is satisfied, then that will give me a solution that I want. Okay. Now, what do I mean by that? Well, here I have a k, right? So what's going to happen is or what was happening was, for the first problem that we just did, solving this for all solutions, right? K could have been any integer. K is any integer. But now when I have this restriction, x between pi and 3 pi, some k's are going to not work, right? Because if we think about it, right, essentially our problem is looking at these, that's terrible, is looking at these oscillations like this. And in general, what we've been doing is we've been finding perhaps two solutions and then propagating those two solutions by k equals 1, right? And then next is k equals 2 gives me that one, k equals 2 gives me that one, and so on, right? K equals minus 1 gives me this one, k equals minus 1 gives me this one. right? But if I'm restricting myself to only between pi and 3 pi, so let's say between here and here perhaps, right? Then some of the k's are not going to be any good, right? This k is not going to work. This one's not going to work. This one's not going to work. The ones out here is not going to work. So only certain k will put me inside the interval that I care about. All right. So essentially what that means is I'm solving for k here. Okay. I want to find a k that makes this expression in here, right, which is ultimately x. I need that to be between pi and 3 pi. Okay. So now I'm just going to solve for k. And that will give me a few solutions. All right. Okay, so here again, this is purely algebra. I'm doing algebra in terms of inequalities, right? Solving inequalities. One thing you'll very frequently notice for these problems, pi here, pi there, pi there, pi there. So the first thing I can do just to make my life a little easier is just divide through by pi. And so I just get 1 less than or equal to minus 1 over 60 plus 2/5 k less than or equal to 3. All right. Okay, that's just a feature of a lot of the problems that we'll see. It's not necessary, right? I could have phrased this problem as up here as solve cosine 5x plus pi over 4 equals root 3 over 2 for x between 1 and 10. That would be a perfectly legitimate problem. In that case, we wouldn't be able to cancel all the pi's. But it just happens that a lot of the problems we see, you can do that. All right, and if you can, might as well, because it makes everything look a lot cleaner. All right, now I just do algebra. This minus 1 over 60, I'm going to add it to all three sides so that I can isolate the k, right? I want to isolate the k. So if I do that, I get 1 plus 1 over 60 less than or equal to 2/5 k less than or equal to 3 plus 1 over 60. All right. Okay, one trick here. I'm not going to simplify 1 plus 1 over 60. I'm not going to simplify 3 plus 1 over 60. I'm just going to continue to isolate. So I want to multiply by 5 over 2 on all three sides. So what I'll get is 5 over 2 times 1 plus 1 over 60 less than or equal to k less than or equal to 5 over 2, 3 plus 1 over 60. All right. Now I'm going to multiply the 5 over 2's in just to clean this up a little bit. 5 over 2 plus 5 and the 60 cancel a little bit to become 12, and then 1 over 24 here, less than or equal to k, less than or equal to, this is going to be 15 over 2 plus, and this is also going to be, sorry, I think this was, yeah, no, this is okay, 1 over 24. All right. Okay. So the reason I'm not simplifying is that I know that k has to be an integer, an integer, right? 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5. So ultimately, if these 1 over 24 terms are small enough, I don't even have to bother with them in a way. We'll see in just one sec. But what I want to do is, because k is an integer, I want to simplify this guy so that it's an integer plus a fraction. All right, so 5 over 2 is 2 plus a half. All right, so this left-hand side is actually 2 plus a half plus 1 over 24, less than or equal to k. This right-hand side, 15 over 2 is 7 plus a half plus 1 over 24. Okay, all right, notice this thing here is less than 1. 1/2 plus 1 over 24, definitely less than 1, right? If you're not sure, you can do common denominators, but definitely less than 1, because 1 over 24 is really, really small. This one here, less than 1. Okay, so let's think about a picture here. I'm saying that k should be between this number on the left. What is this number on the left? If here is 2, then I'm adding a little bit to 2, right? 2 is 3, 3 is here. Let me actually draw this 2, 3. Let me draw 7 here. Let me draw 6 here. Okay, so what's happening is this left-hand side is 2 plus a little bit, right? So that's going to live roughly there. Okay, between 2 and 3. That's the important thing. It's between 2 and 3. Okay, on the right, this is 7. I guess I needed 8. Let me do this. 7 and 8. So this on the right is 7 plus a little bit, right? So it's going to be right there, between 7 and 8. It's really important that I know which two integers it's between, all right? Okay, now why is this so useful? Well, again, because k is an integer, it has to be an integer, so a whole number, right? So k could be 3. Let me do a different color. K could be 3, and then I have 4, 5, 6. So k could be 4, could be 5, could be 6, could be 7. It cannot be 8, right? And it cannot be 2, because I need k to be between this red dot and that red dot. All right, so I've concluded that I need k equals 3, 4, 5, 6, and 7. All right, so those 5 values of k are going to give me solutions to the full problem up here. All right, and of course, each of these values of k correspond to a different x. Right, so let me actually write them all down. X equals minus pi over 60 plus 2/5 pi times k. K equals 3, so times 3. Okay, another one. X equals minus pi over 60 plus 2/5 pi times 4. X equals minus pi over 60 plus 2/5 pi times 5. X equals minus pi over 60, 2/5 pi times 6. X equals minus pi over 60 plus 2/5 pi times 7. All right, so what I wanted to emphasize the fact that, I want to write these down to emphasize the fact that all of these guys are just numbers. Number, this is a number, that's a number, that's a number. There's no more unknown things on the right-hand side. There's no k's or anything like that, right? It's all numbers. And in fact, if you wanted to, you could just compute what these fractions actually are, right? So for example, this very first one is minus 1 over 60 plus 6 over 5 times pi, right? And if I wanted to simplify that, that would be 60 minus 1, 12 times 6 is 72, right? So this would actually be 71 over 60. Sorry, I should put the pi in. So this would actually be 71 over 60 pi. All right, so this first solution corresponding to k equals 3 is actually 71 over 60 pi. All right, so it looks ugly, but it's actually just a regular number. And you can do the same for all of these other 4. And so ultimately, we get from the left-hand side of the screen 5 solutions to our problem. All right. Okay. Now we go to the right-hand side of the screen, because there's going to be more from this right-hand side, right? We also have these guys on the right-hand side as solutions to the full problem. But again, we don't want the full problem. We only care about x between pi and 3 pi. And we know x is this expression right there. And so we just substitute that expression in. So pi less than or equal to 19 over 30 pi plus 2/5 pi k should be less than or equal to 3 pi, right? And then the k that solves this inequality are going to give me solutions to the right side of the board, or the right side of the screen, right? Just like the left side of the screen. So we're literally doing the same things, except with different numbers. 19 over 30 instead of, I think it was 1 over 60. Yeah, all right, minus 1 over 60. But in any case, we're doing the same thing. So this is the same as 1 less than or equal to. So again, we can cancel out the pi's from all of them. Makes our lives a little easier. And then we can subtract 19 over 30 from all 3 sides. So here, 1 minus 19 over 30 is going to be 11 over 30. 2/5 k less than or equal to 3 minus 19 over 30. Let me leave it like that for now. All right. Okay. I actually I probably could have done that for this left-hand side, but 1 minus 19 over 30 is relatively easy to do. So I might as well have just done it. All right. Okay, I multiply 2/5 on both sides. So this is 11 over 30 times 5 over 2, less than or equal to k, less than or equal to 3 minus 19 over 30, and then times 5 over 2. All right, let me simplify that. Left-hand side simplifies, I get some cancellations. This is 6, 12, 11 over 12, right? K, less than or equal to. And this left-hand side is going to be 3 times 5 is 15 over 2, minus, and then this right-hand side is, I'm going to get some cancellations again, 6, 19 over 12. All right. Okay, now this left-hand side is clean, right? It's again, I want to write it as a whole number plus a fraction less than 1. So this guy is already a fraction less than 1, right? So I'm all set here. This right-hand side is a little messy, so I'm going to rethink it as 15 over 2 is, like we said, just like on the left-hand side of the board, actually, 7 plus a half, all right? This minus 19 over 12, 19 over 12 has a whole number in there. So this is actually minus 1 plus 7 over 12, right? Because 12 plus 7 is 9, so I get 19 over 12. So this guy here is actually 7 minus 1. Let me write it all out. 7 plus 12 minus 1 minus 7 over 12. That's 6 plus 1/2 minus 7 over 12. All right? Okay, the important thing here is the whole number, 6, and then this 1/2 minus 7 over 12 is a negative number. So this one maybe we should write it out just so that we don't make a silly mistake, right? Because I need to recognize it's a negative number, all right? So this guy is common denominators, gives me 12, 6 minus 7. So that's actually minus 1/12, all right? So this is getting a little messy, so let me conclude it here. 11 over 12, less than or equal to k, less than or equal to 6 minus 1/12. All right, so my k has to satisfy this. And if I draw a picture, 11 over 12, so here's 0, 1, 2, 3, 4, 5, 6, right? We don't actually have to draw all the intermediates. Let me just put 6 here. I just need 5, right? And let me draw 1 as well. 1 is here. Oops. Okay, so 11 over 12 is just less than 1, so it's right there. All right, 6 minus 1/12 is just less than 6, so it's right there. Okay, we need k to be between this dot and that dot. And k has to be an integer, it has to be a whole number. What does that mean? It has to be 1, 2, 3, 4, and 5. Okay, those are the only whole numbers between these two red dots. So k equals 1, 2, 3, 4, and 5. All right. So this second part of the board, or second part of the screen, is going to lead me to 5 more solutions to my problem. All right. What are they? Well, my instructions for the x for this right side of the board was 19 over 30 pi. So x is equal to 19 over 30 pi plus 2/5 pi k, right? And here I've discovered that k should only be k equals 1, 2, 3, 4, 5, right? So if I wanted to write them all out, right, then it would be x equals 19 over 30 pi plus 2/5 pi times 1, right? K equals 1. And then I'm going to have x equals 19 over 30 pi plus 2/5 pi times 2. X equals 19 over 30 pi plus 2/5 pi times 3. X equals 19 over 30 pi plus 2/5 pi times 4. X equals 19 over 30 pi plus 2/5 pi times 5. Oops, sorry, I had it paused for a bit. So the last thing I said was this guy is just a number, these guys I just found, they look ugly, but they're just numbers. You can simplify them as numbers, right? Something pi, some fraction times pi. So ultimately we have 10 solutions, and we're all set, right? That's our solution to our problem. We've got 10 different solutions. Most of the problems you'll see will be a little more simple. We won't have 10 solutions, maybe 4, maybe 3, something like that. But the procedure is all the same.